Hi, I'm Garrett with IDC Woodcraft, and I am so glad you've come to this video, especially if you are brand spanking new to CNC routers. I'm talking to the person who is just getting ready to order one, all the way to the person who has got it built, it's all set up, and you're about ready to cut a project, but you haven't cut anything yet. Or maybe you've tried. This video is intended to save you a ton of time. I shoot a lot of videos about CNC routers and the design projects. I tell you about router bits and how to make money with a CNC router or any CNC machine. And as a result, I get a lot of questions, and I have seen a pattern in those questions. Basically, these questions come up over and over and over again, which means it's not out there, or it's really hard to find the answers to. So you spend a ton of time on YouTube or in Facebook groups trying to figure this stuff out. This video is intended to answer a lot of questions that you have or are going to have, guaranteed. What I'm going to do here is take you through a process from start to finish of a design as a beginner on a CNC machine or a router in the right way. What we're going to do is we're going to design up a square and a circle. Really the place that you should be starting, not at a complicated project. I've seen way too many people ruin a good piece of wood, break router bits because they got way too gung-ho in the beginning, ready to make something. I mean, I know what it feels like because I was like that too. But I want you to put the brakes on and just follow along with this process here of what we're doing and why. The reason we're doing a circle and a square is because we're going to check your CNC router to make sure it works right. And we're going to do a couple other things, like dry run your machine in the beginning so you know how the thing runs. Let's look at CNC routers kind of like a marriage. You can't just jump in and be married. You got to kind of buddy up with it, get to know it, build that relationship with it. You got to know how the thing works. So that's why I want you to slow down, watch this entire video, get all the tips and tricks that you're going to get in this video, which you just don't find out on YouTube, as far as I know, at least not compiled into one video, and get all your questions answered at the same time. We're going to take this a step at a time, all the way through the process, and I'm going to try to explain every single part of this, from the design of this to generating toolpaths, to generating what's called G-code, or the language that your CNC router understands so it knows what to do. And then we're going to take the G-code files and we're going to transfer it from the computer over to the control for the router. And then we're going to do a few things from there. I'll talk to you a little bit about router bits, miscellaneous things. But you're going to learn a lot along the way. And you're going to learn more than what some more experienced CNC router owners know. You're getting little tips and tricks. So watch this thing all the way through. It's a long video, but you're going to learn more in this 1 hour than you will in 40 hours of searching around on YouTube. That's a promise. So without any further ado, me, you, the long mill, and the software are going to walk through this process. Let's go. Okay, we are in the Vectric design software. I just want to remind you that you can do this in virtually any of the softwares that are available out there. Of course, they each do it in their own different way, but when push comes to shove, the process is still the same. So what we're going to be doing is we are going to first design up our square and our circle to check our router, and then we're going to do toolpaths, and then we are going to take that G-code and I'm going to show you how to get it into your control software. I'll explain what that is when we get to it, and then we're going to run the little test program out on the router. So you being the person who has just gotten into this and some of these little things that you might be struggling with, hopefully we'll get them answered here. So I'm in Vectric. This is desktop. And the first thing we're going to do is just create a new file, which is right here. Typically, when you open up Vectric, you're going to see something like this, with this stuff on the side. This is your job setup. And what a job is literally the piece of material that you're going to be working on. So what's out here would be the piece of wood, piece of aluminum, brass, glass, and we want to get it to the proper size. So the piece that I'll be doing the test cut on is 13 wide by 8 tall, and it's 3/4 of an inch thick. Since our test cut is on the top of the surface and we're not cutting through, we're going to set this to the top of the surface. And then we're going to set off the center of the project. All right, and then you want to be set on standard right here for your resolution and click OK. So we're going to quickly draw up these two shapes. They're very easy in any of your softwares. They're very basic. First thing we're going to do is create a circle, and that circle is going to be on center right here. So we select our circle command, and we want our circle to be 5 inches in diameter, so we're just going to click 5. We want to select the diameter button, and we want it to be starting off the center of the project. So that's what these two boxes are for here. So you want your X to be 0, your Y to be 0, and then I click Create, and you'll see now we have that circle on the center, and that circle is 5 inches in diameter. So we're going to close that, and then go to Rectangle, and select that. Now, in the Vectric software, you have options of selecting your rectangle start point off the center of the rectangle, or any of the 4 corners. We want to go off center, and again, we want our X and Y to be 0. We want our rectangle to be square on the corners, so we have that selected, and our rectangle size is going to be 6 by 6. And we click Create, and there's our rectangle. So we close that, and now we're done with our shapes. If you are a Vectric user, then listen in, because I'm going to teach you about a bad habit that I've seen a lot of people make or do when they're dealing with the Vectric software, when I do a lot of one-on-ones. It's just not a good habit. Let me explain. Let's get back into this. Whenever you are doing shapes or text, drawing lines, you're working in what's called CAD, computer-aided design. And that's what this whole area is over here. It's for your computer-aided design. As far as creating toolpaths, that's a completely different process. That's called CAM. Now, if you use the Vectric software, I've seen this far too often. People use this tab up here in the upper right corner, way up there. And this area pops out here, this toolpath area. This is the wrong way to do things. And the reason is because this area over here is your CAM area, completely separate from this on the left side, which is the CAD area. I always encourage people to toggle between the two rather than pull menus out like that. This is meant for quick fixes. Okay, so the way to toggle between the two is this little blue button right up here. So you select that, and you can see now we are in the CAM area. So now we're just going to cut a profile out around the square about 1/8 of an inch deep, and then we'll do the same thing to the circle, and we'll do it with a 3/16 diameter end mill. Now I want to take a minute and explain to you what profile is, or a profile cut. So we just designed a square and a circle, and we're going to cut these out. And the way to cut them out is by following the line of the square and the circle, or following the profile. So what a profile cut is, essentially, you are cutting along a line that you've created. It can be a curve, it can be an arc, it can be a closed box or circle like this, letters, anything. As long as you're tracing along the lines, that's what's called a profile. Now let me give you another example of what I mean, and this will probably give you the aha moment. So right here we have a deer head, and this was cut out on a CNC router. Interestingly enough, someone just took the half, had that drawn out, and they flipped it over or mirrored it, and then they cut it out. But it's very clear, in order to get that deer head, you have to follow the outline of the deer head and the antlers. That is a profile cut. So now I think you got the aha of what a profile is. Now I'm going to just tell you what the difference is, because sometimes you're going to hear the word pocket. As a matter of fact, a lot you're going to hear the word pocket. I created a beginner's video project that any beginner can make, which is this house number sign. I'll put a link down below in the description. And you can see that it has raised numbers on it. The boundary around it is also raised. That means that we had to cut out the material inside here like that. That's called a pocket. So if we just cut along the lines of the O, that's a profile. If we cut out everything around the project to recess it, that's a pocket. If you got an aha, give me a thumbs up. Why am I doing it with a 3/16 as opposed to a 1/4 inch or an 1/8 inch? The reason is because a 3/16 is like the silver bullet of CNC router bits for the straight flat bottom bits, because the 3/16 can replace both the 1/8 and the 1/4 down bit. That's why I added it to the IDC Woodcraft store. If there's an interest in that bit, there's a link down below, and anything else I show you, there will be links in the description. Okay, so what we're going to do is we're going to cut around the outside of this square and the outside of the circle, and that will enable us to measure across the square to see if it's 6 inches, and then of course up and down, and then across the circle to see if it's 5 inches. So we're going to cut that using a profile toolpath, and that's what this button is right here. So we're going to select the profile, and now we're going to select our shapes. So we're going to select both the rectangle and the circle. Okay, so I'm going to show you a little trick. Even if you've been using Vectric for a while, pay attention to what I'm about to show you, because this will give you like that little edge up on making better time on your projects when it's running. Watch this. Notice that when we selected these two, there's a little green dot right up here at the top of the circle and one down to the lower left corner of the rectangle. Those are considered start points for the router bit. What that means is when the router comes to cut the circle, it's going to start up at that green point there, and then it's going to make its cut around clockwise or counterclockwise. Same thing with the corner down here. Now this is just an efficiency thing to think about in the future. When a bit comes all the way up here and it's done making its cut, it's got to pull out and then travel this entire distance to start this cut, and that's always time consuming. What I mean by that is that one dot is right here on the circle, the other one is down here. So what the bit is going to do, it's going to start here, make its cut all the way around, and then pull out and have to travel across that entire distance there, and then come back in and make the circle cut. That travel time added up over multiple pullouts that your router bit is going to do on complicated projects adds up a ton of time on the runtime of your CNC router. So that's what we're going to fix right now. So we're just going to do a quick fix up. What we're going to do is close this toolpath out, and I am going to press the N button while the rectangle is selected. Now we have them both selected, so that's okay. I press N and you see all these little dots come up. These are called nodes, and these are transition points for the software to generate its G-code from. And you'll notice that there's a green node at the top of the circle, and there's a green node at the lower left corner of the rectangle. The green node represents the start point of these vectors that we've drawn. So that's why that's happening. So in order to change that real quick, we're simply going to hover over the upper right corner of the rectangle and we'll press P. And what that stands for is start point. So now you see we have a green node there. So that's going to be the start point for that. Okay, so we are done with that. I'm going to hit escape, and we're going to reselect these things, and we're going to go back into the profile toolpath. So we select that, and now you see the 2 points are closer together. So this will be a little bit more efficient. Essentially what we just did was, instead of having the router bit start down here and then when it finishes that cut have to come all the way across that distance to go here, now we got the start point here, it'll come all the way around, and it only has to travel that distance instead. Here it doesn't matter, but in the future you want to pay attention to that. Okay, so first thing we have to do is just tell the software where we're going to start at, and we want to start it off at the top of the material, so we're going to say 0, and then our depth of cut is going to be 0.125, 1/8 of an inch. And then we have to select the bit. So we currently have the 3/16 bit selected, so we're just going to go with that, and so I'm going to cancel, but you would just hit the select button and change or select the bit that you want. Now It's always good to check the edit button just to take a look at the feed rates of the bit. So you see I have a 70 inches per minute feed rate and a 70 plunge rate. So I'm going to be plunging directly into the material. I'm going to slow that down a little bit, so I'm going to make that 25. The reason I had it at 70 is because most of the time I don't do a direct plunge. I will ramp into the material. In this case, we're going to do a direct plunge. I will select OK, and now we've changed that plunge rate. Now, we are going to be running around the outside of each shape. So we want to tell the program that we are going to cut around the outside, and so we want to have the outside selected. If we selected on, then the bit would be cutting over center on the shapes, and then we would not be at 6 inches. So we want that to be on the outside. Now I want to take a minute and explain to you, when you're doing a profile cut, what on the line, inside the line, and outside the line mean, and why it's so important to pay attention to it. So let's just pretend that this square piece of wood is the square that we have drawn. And we ultimately want the piece of wood to be this size, or the cut to be this size. And in this case, it's 6 inches wide by 6 inches tall. And that's what we want to be able to measure. We actually want to get our calipers or our measuring tape right on there and get to know what that size is. Okay, so we got that down. Just pretend this is the line, the square that we drew. Let's pretend this roll of electrical tape is our 3/16 down cutting end mill that we're going to be using on this to cut this so we can measure it. When we tell the software to cut on the line, it is taking the center of the bit and it is putting it directly on the line, and it's going to cut around just like that. So there's a problem here, because now we have cut out half the diameter of the bit on this side, half the diameter of the bit on that side. When you add that up, that's 3/16. We are now 6 inches minus 3/16 in our size. When we're telling it to cut inside the line, it's going to take the edge of the router bit, or the center of the router bit. It's going to split the diameter in two, and then take that difference and move the router bit inward so that this edge of the bit will cut along the line. And therefore, we're cutting a profile inside the box that we have drawn. And now we have a box that is 3/16 plus 3/16 minus 6 inches, even smaller. In this case, we want to be outside the line. So outside the line, we'll take the router bit center, split it in half, and then add that to the size that it's going to be cutting, and now it's going to be cutting around the box like that, therefore giving us that 6-inch box on each side, or that 6-inch measure here and here. So I hope that explains to you and clears up specifically in profile what inside the line, on the line, and outside the line mean. If so, give me a thumbs up. And then we will simply click at the bottom, calculate. Alright, so there are our tool paths. Now we want to take a look at a couple things. First of all, we had sharp corners on the rectangle, but you see it's rounded here. This will still create a sharp corner. Basically, the edge of the bit is rolling around the corner. This path is literally the center line of the bit. Remember, the rectangle is on the inside just a little bit. Now, what I'm going to do is I want to show you the tool path in a different way. We're going to go up to split screen right up here at the top, and we're going to take a look at both screens, the design screen and the toolpath screen. And you notice that there are the dashed lines. These are the areas that we've selected. And then there's another line that has arrows on it. There's one here by the rectangle, one by the circle. The rectangle arrow lines, or the arrow lines in general, are the center line of the bit as it's going to be traveling around its cut. And you can see on the rectangle, that line is on the outside, which is exactly what we want it to be. So that effectively, this will be the 3/16 bit circle right there. And this line is the center line of the bit. But you notice on the circle, it's actually on the inside. So what Vectric is doing, it is seeing this as a solid area, and so it's going to look for the next line and put the bit on the other side. So we're going to have to create two separate toolpaths for this. So what we have to do is go back into that toolpath we just created, and we are going to come over to this design area, hold shift button down and click on the circle so it gets deselected, and then we're going to come back and calculate that. So now we're just running the rectangle. As you can see over here, the circle is not being touched, and it shows up over here by the blue line being our toolpath. Here's a little shortcut for you. Instead of having to create a brand new toolpath for the circle, we can just come into this toolpath, right click it, click the duplicate button, and now it has created a duplicate of this one. So now we know that this one is going to be the rectangle as well. So we're just going to click into it and come over to the 2D area and select the circle without holding any buttons down, and you see now the rectangle is no longer selected. And then we're going to leave all the other settings as they are, and we'll just change the name since we have now a second toolpath. We're going to call it circle, and we will calculate. And now the toolpath is on the outside. That's exactly what we want. So we're going to come back over to this first toolpath. We're going to right click and rename it square. Enter, and we are set up. So we just run this out real quick. So we will run preview all toolpaths. We click that, and that's what we have. So I want to make sure that it's only one pass per. What I mean by passes is the number of times it needs to go around to get down to the depth that it needs to get to. So I'm going to slow this down for just a moment, and by moving the slide bar, and do that again. Preview all toolpaths. And see, the rectangle is going twice and the circle went twice. There's a reason for that. We're going to go back into both of these. I'm going to select the rectangle first, and I'm going to go to the edit button, and here is why I did two passes. Up here, our depth of pass is 0.125. That's our final depth. But here, under pass depth, we are telling the software we can only go 0.1 per pass. So it has to make that second pass to reach 0.125. So all I'm going to do is add 0.025 to that. So now it says 0.125. Click OK. Calculate it. We'll do the same for the circle. Click OK. Calculate. And now we are going to reset and preview all toolpaths. There's the rectangle and there's the circle. So now we're good to go. Okay, so now you know how to run a simple toolpath, and you learned a few things along the way. What we're going to be doing now is how to create the G code, or the file that's going to make the long mill CNC router run, or any CNC router. A few things that you learned here. You learn about moving the nodes so you can get your router bit to start at a different point. You learn about setting up the depths, and you learn that interesting thing of how to create the toolpath on the side that you want it to. You remember that it was on the wrong side of the circle, and we had to get it on the right side of the circle. And that was just a little thing in Vectric that we have to compensate for in a different way by duplicating a toolpath, which is something else you learned. Hey, if you're learning something here and you appreciate what you're learning, give me a thumbs up. And you might want to subscribe if you're brand new to the CNC router stuff. What I'm giving you is the basic stuff, and you are learning how to get this kind of stuff up and going really fast. This is stuff nobody shows you how to do. All right, so let's get in here, and I'm going to show you how to save the toolpath, and then we're going to get into getting it over to the router and making the router move. So let's go. All right, so in order to save the G code, we need to go to this button right here in the Vectric software where it says Save Toolpath. Select that, and a menu is going to open up. Now we know that we are working with a 3/16 diameter flat bottom end mill. This is a down cutting bit on both of the toolpaths here. So we're just going to select toolpaths. So we select all of them. Then we're going to come up here and make sure we are Writing G-code for all visible toolpaths. Now, visible toolpaths are anything that is selected down here, which is both of them. And then you want to make sure your post processor is set up. Post processor, what is that? I have to take a minute out and just give you a brief overview of what a post processor is and why it can be really important to your CNC machine. So a post processor is a little program that tells the CAM software, in this case it's Vectric, but any software that creates toolpaths, it tells it how to write the G-code file that's going to run your CNC router. Sometimes CNC routers have specific commands, so I'll give you a pretty basic idea of what I'm talking about. Right here on the long mill CNC router, we have a trim router that is mounted on the router that actually does the cutting. And it's very common on these type of CNC routers. That trim router has an on-off switch, so we manually turn it on and off. However, some routers have what they call spindles, and spindles are controlled by the black box, the controller that runs the CNC router. So that does not have a power switch, so the software, the G-code, is going to tell the controller when to turn that spindle on, how fast to make it spin, and then when to turn it back off again. And so when you have a spindle, the post processor is going to tell the CAM software to insert the codes that are going to turn that spindle on and off. Now, that's just one example. There are various other examples. For example, if you work in millimeters or inches, that takes a certain code, and your post processor is going to tell the software that it needs to be written in metric or in inches. So this post processor thing is kind of important. If your post processor is not on the list and you have a CNC router that may be the long mill CNC router, Onefinity, Bob CNC, any of these like home-based benchtop type of CNC routers, most likely 99% of the time they have the Arduino-based platform or circuit board and firmware that they're working off of. And in that case, and you can't find your post processor in this list that I'm going to be talking to you about, then just pick the GRBL or the Gerbil post. It's going to pretty much work for your machine, and if it doesn't, you'll get an error along the way and your machine won't run. Anyway, let's get back into this. I'll talk to you more about this post processor thing. I just wanted to make sure you understand what a post processor is and why it's an integral part of this entire process of getting your CNC router running. Come on, let's get back into this. Now we're doing the long mill CNC router, and so the post processor to use for that is the Gerbil inch or GRBL inch post processor. You click that and you get this long list of different machines here. Just find the Gerbil and use that, and actually the Gerbil works for the majority of machines out there. And then we'll just click the Save Toolpaths. Now it's going to open up to a directory. Okay, so now we're ready to literally save the G-code. But there's a couple different scenarios that can happen here, so I want to kind of talk about that first. Number one is if you're running your CNC router directly from the design computer that you're doing your design work on, and that computer is actually connected to your CNC router, then you will save the G-code to somewhere on your hard drive. The second one, which is the technique I use, is I have a dedicated laptop that runs my CNC router. And most CNC router owners do this. It just keeps things simple. You can do your design work up in your office, what have you, and you'll have your CNC router in your shop, your garage, basement, whatever it might be. That way you're not tethered to the router while it's running or whatever it may be. You got a separate computer that's actually running it. And that is what I recommend you do. Some people actually have this laptop that's running a router not even connected to the internet. I'm not like that. I like to keep my files updated, and I've never had a problem with that. So if you want to have a second laptop, the control software that will be running your CNC router does not take a lot of processing power. And so you can buy a cheap laptop. If you have an older one, that's good. This is an older one. It's probably about 10 years old. It runs just fine, or runs the router just fine. If you don't have a second laptop for that, I've got a couple links down below for a couple that I found on Amazon that are really inexpensive. There is one thing that you definitely want on a laptop, and it's you want 3 USB ports. You want the one where the router plugs into it, you want the one for the flash drive to plug into it, and sometimes you have a wireless mouse and you need that to plug into it. So at least 3, maybe 4. But the ones that are down below in the description, those have 3 ports, you'll do just fine. Now there is another scenario with this G-code stuff where you load your G-code onto a flash drive and you literally plug it into the control box of the router and simply hit a go button. And I don't like that one little bit, because you can't see what your router's doing. You don't have control over it. There's nothing you can tell because you don't have a nice control display to run your machine and pause it or whatever you need to do. So, a little winded, but the 3 scenarios I'm just going to rehash. One is if your design computer is tethered to your router, then you can save your file directly to the hard drive. If you use my kind of setup, which I totally recommend, a second laptop dedicated to the router, then you're going to want to put it on a flash drive and transfer it over to this machine. And the third scenario is the putting it into the black box. Just put it on a flash drive, stick it in a black box and hit and go. Don't do that. If you're stuck with that, I'm sorry. So what we're going to do is we're going to put it on the flash drive here, and then we're going to transfer it over to here. All right, I know that was a little winded, but I hope that gave you some insight. Get a cheap second laptop. If you can't really afford it, just do your work off of this guy here, your primary design laptop, and you'll do just fine. Okay, so let's go on back to the stuff. Okay, so now that you know I'm going to use a flash drive, I'm going to put my flash drive into the computer. And then I am going to open it up. If it shows up, there it is. And I'm just going to save this program to the top level. And I'm going to call this program Test Router. And simply click Save. All right, now let's just take that out and put it over in here. And now we get into the control software here and start moving the long mill CNC router around. We are now on the other computer that's running my CNC router. So controller is the device that actually runs your CNC machine, where it's like a display or readout. You'll have heard of several of them. You might have heard of Mach 3, Mach 4, JS, CNC, Universal Gcode Sender, gSender. There's a whole spew of them. So the most common one that's out there right now is this one. It's called Universal Gcode Sender. And I am not a user of this anymore. I used to use it. I use gSender, but I'm going to show you how to work with this briefly to get your project loaded in. Now this is not connected to my router. I'm not even going to connect it because I don't like using it anymore. But when you have it loaded up and you're ready to bring your file in, you simply come over to this File Open button, select it, and then find the directory where your file is at. So we have a test router right here. So if I click that, double click it, and now you can see there's a circle on here, and the rectangle is, oh, where does it show? It's right there. You can see it right there. So that is our project in Universal Gcode Sender, and that's how you load it up. And then once you have your machine set up and zeroed out, then you'll simply hit the button right here and hit go. Now, we're not going to be using this, so I am simply going to get rid of this, and we're going to go to what I do use, which is gSender, a much smoother program or lighter weight. It's designed and it's current to the most current Windows. It's got a lot of features you will not find in Universal Gcode Sender or any of the other control softwares, and it's got a much more pleasant layout. And you can see it's just a very clean layout. I really like it. And gSender, you can get it off the Longmill website. It's completely free and it works on any CNC router out there that takes the or works off the Arduino platform. Okay, so the first thing we need to do is make sure our router is connected, and that's with using this little box up here. When you hover up, you'll see a little flashing icon there. It looks like a plug, and it's going to drop down and simply come down until it highlights and then select. And then when you see a green checkbox, you got it. Now the other thing you're going to see when you hover over it, it'll say disconnect. So if you click it again, it's going to disconnect the router from the software here. And so now we have to just click the unlock machine, and we're going to send the machine home. Okay, so while we're waiting for the long mill to get to its home position, a couple things I just want to tell you. If you're brand new to CNC routers, subscribe to the channel because I cover all the basics for you. Also, I've got a lot of links down below for you. Videos for beginners, reviews, even on the long mill CNC router. And if you don't have a CNC router yet and a long mill may be one that you want to use, when you do your research, I'll ask you to just use that link down below that says long mill website. What happens if you decide to buy the long mill? I get a little bit of a commission. It helps support me in what I do here. So I don't have to go back to work. I can make videos for you. But there's a lot of other links down below. Talk about router bits. There's other video links down there for beginners to help speed up your journey into CNC. Okay, let's get back into the controller and move on with this little testing of your CNC router and learning how to handle all this G-code stuff and all that other stuff. Come on. We've got the machine ready to go, and now we're just going to load up the program. In the gSender, you simply come down to the load file button here, select it, and then you go to wherever your file is, and there it is, test router, and it loads it up, and there we go. So that's it. All you have to do is put it on a flash drive, put it into a directory, load up the gSender in the computer that you use for your router, and then simply hit the load file button. Now here's a little tip for you. If you want to delete that file and come up with something else, you can either hit load file again and you'll bring up a different one. So let's just bring up one I did a video on right there, and then I want to bring the other one test back, and there it is. Or you can just hit the X button, that'll unload the file. Now all we have to do is basically hit the go button, but we have to set the router up first, so we're going to take care of that right now. So right now the long mill CNC router is in the home position, which is the front left corner, and obviously I can't work on it right now like that. Now the home position, just so you know, the front left corner is traditionally the home position. So when you get your homing switches for this, then you want to set it to the front left. I will do videos on that. Okay, let's get this thing back out of the way. So we're going to go into the control software and simply move it back. So to move it around, you just go to this manual area over here, and that's these buttons, these blue buttons are your different motion buttons. So your Y plus button will move the router away from you. Your X plus button will move it to the right, and of course C plus will move it up. And then the other buttons are respective to that. And then the little angle buttons there, that'll move the machine out away. So I'm just going to push this one right here. We're going to go Y plus just to move the router straight back. Now before I actually press that, I want you to notice over here we have three different buttons. So these buttons determine the speed at which the router is going to move. You have very slow, so you get good control over it, kind of a moderate rate there, and then this is a rapid rate. That's the button we want to be set on, and when we change it, we're going to change these numbers down here. So for example, the XY, it says 0.2. And when I go to rapid, it says 1. So that's really the distance that it's going to be traveling. But if you notice, the speed here is 250 inches per minute. When I select the normal, it's going at 118 inches per minute. When I do the precise, it's going at 100 inches per minute. So we're just going to set the top button, and we're going to press the Y now. Okay, so now that we have the router out of the way, we got to get our project piece down. So I'm just going to say, when you're doing this kind of test, keep yourself with cheap wood. Don't try this with the good wood. And this is something you always want to do before you work with your router. In the beginning, you just want to know what it's doing and how it works. In fact, before we even cut, we're going to do an air cut. But we're going to get the project set up first. So there's a couple ways you can clamp this board down to the table. The traditional way is by using regular clamps. And that's usually what I use, but there is another technique that you may not know about that I haven't shot a video on about, and we're going to cover it right now. It's using CA glue. You've probably heard the term. It's this. It's basically super glue. That's a big bottle of super glue. This is made by Starbond, and Starbond is really well known in this industry because it can do a lot more than just hold stuff down, but we're going to deal with that right now. So they've got a spray that you use as well. This is what they call an accelerator. When you put the glue down and you spray this, it dries and cures really fast. So we have that, and we're going to be using painter's tape and a putty knife. So I'll show you how this works right now. So the first thing you want to do is make sure your spoil board is as clean and free of dust as possible. And then the same thing with your project piece. Now you see I've got some cuts on there. This board is from when I originally checked my CNC router. And we're going to take 3 strips of painter's tape. Make sure there's no buckles in it. We're going to put it across the project. One on one edge, one in the middle, and one on the far end. There's no rocket science to this. Then we're going to take the putty knife and press it down. Now what we're going to do is just get a general guide as to where the tape is. So I'm going to take 3 pieces of painter's tape and just use it as markers where the strips are on the board. And then we'll put strips down on the spoil board in the respective locations. If you make a mistake, pull it up and put it down again. Links for the CA glue stuff is down in the description. Okay, now we're going to take our putty knife, press the tape down here as well. And we're just going to double check, make sure our strips are lined up. And now we take the CA glue. Now this is the thin stuff. It's like regular super glue. And this is Starbond brand. I said it's a very well known brand in the CNC industry, woodworking industry. And we're going to take it and run a bead down each piece of tape. Now you don't want it too light, but you don't want it too heavy. If it's too heavy, it will squish out onto your spoil board. Make sure you cap it back up because now we're going to use the accelerator. The accelerator makes that glue set very rapidly. So a quick spray on each one. Then line up your board. And hold it down for about 5 or 10 seconds. And before you know it, your project is secured to the table. Now we're going to put a center mark on the board because we got to set up our router for the work, and our project is off center of the board. Center of the circle, center of the rectangle, and so let's get the machine in position, and we're not going to put a bit in yet. We don't want to put a router bit in. We are going to dry run the machine. But one of the things we want to do is just take the Z down a little bit, not down to the surface of the project, but just down. Now that we have the router generally set, we don't need to be exact right now, but we've brought the X and the Y relatively close to the center of the board, and Z is down a little bit. So now what we're going to do in the gSender is simply zero all three of these where it's at right now by clicking this zero all button. So when I click that, you see all these three numbers went to zero. And now all we have to do is just hit the start button without turning the router on, because we want to make sure that the router is going to do what we expect it to do. So you might be wondering, why are we doing an air cut without a router bit, without turning the router on? Well, there's two reasons, and both of these reasons I've seen so many times that I have to sit here and talk to you about this. Unfortunately, I've seen way too many brand new CNC router owners get way gung-ho, and as soon as they get their machine in and they do a little bit of design work, they put a router bit in and put a nice piece of oak or a piece of walnut down, they're premium wood, and they hit the go button without understanding how the CNC router works or how the G-code is going to be working. And what inevitably happens is they end up botching the job by getting all kinds of miscuts in a nice piece of wood, or they break the router bit, brand new router bit at that. So that's why I'm sitting here telling you, whoa, Nelly, put the brakes on. Let's go through this kind of process right up front until you can get used to the machine and how it's going to be cutting. And then you start putting on the good lumber. Please, just do it this way. And this is exactly why we're doing this. So now we're just going to hit the start button here and watch it run out. It'll be very quick. And we are off and running. And it is cutting the rectangle first. Well, it's just moving along that path. So just so you know, this is a CNC machine. CNC machine is a CNC machine. It's what you have on the end that makes it what it is. In this case, a CNC router. So it's just going to move around the way you tell it. It doesn't care what's in the machine. And by the way, I have a story to finish with you, that pistol to the head story. So I will tell you after we're done with this little section here. It's cutting the circle now, or moving around the circle, and now we know that it works. It's moving just fine. So it's time to put the bit in. So we're going to put the 3/16 down cutter in, but not just yet. We're going to brush our teeth first. Now, really, we're going to use the toothbrush to help get any sawdust out of the components of the router, in the nut, in the collet, and in the shaft. Because whenever you're cutting, sawdust gets up in there and it causes problems. It'll actually affect the holding of your router bit. And when you're having that kind of problem, over time you're doing a nice job, it's cutting for an hour or 2 hours, and that router bit slowly starts to slip down into your project and starts to ruin the project, and there's nothing more frustrating than that. I did a video about sawdust, a couple of them. You want to understand that. Just know, get the sawdust out every time you change the bit. I can't stress that enough. And tighten things up. If you have a Makita router, you have 2 wrenches, use them both. Don't use the red pin on the router to try to tighten things down. You'll break your router. And now we have to set our X, Y, and Z 0. So what we're going to do is set the X first. And we're going to switch from rapid to normal in the gSender software, and we're going to move it around and get it over that X that we have on our board. And now if you go to the top area and you have X, Y, and Z buttons. You see next to the X it says 0.4, minus 0.4. You click the X and it goes to 0. Same with the Y. It says 0.4 right now. Click the Y and now we're at 0, but we're not going to do Z there. We need to set the Z to the proper height, which is the top surface of the material. And we're going to do that with a touch plate, and this is it. It comes with a long mill. It's an aluminum plate and a little magnet. They're wired together in such a way that when the bit touches the plate, it'll close the circuit and it'll set your Z0 for you. Very easy. I always recommend touch plates. Right now the plate isn't fitting in, so we have to raise it up a little bit. One thing, don't take it too far over the plate. maybe half of an inch, 15 millimeters, whatever, because when you try it, it'll set off an alarm if it has to travel too far. And then attach the magnet to your router. And now we're going to go down to that touch plate area. You see right here it says Z Touch. Now you have several options here. When you click the drop down menu or drop up menu, it says Z Touch, X Touch, Y Touch, XY Touch, and XYZ Touch. We're going with the Z Touch. So there's a button down below, and you click that button to start the cycle, and you get this box come up, and it doesn't start to move. This is the most brilliant thing that has been added to any control software, and gSender is the only one that has it. What this does is there to confirm that you have things set up properly. What happens is when people don't have it set up properly, sometimes they forget to attach the magnet and they run the cycle, and the bit comes down and runs right into the plate, and when you have a pointy bit, it breaks the bit. So this little thing is going to confirm that you are set up right. Now you see this little red light down here, and the switch or the button here is grayed out, and my cursor has a hash through it. That means we can't start the cycle yet. We have to actually literally touch the plate to the bit to get that light to change. And then the button will change and we'll be able to start the cycle. So we lift the plate up and touch it, and you see the switch turns green and the cycle start button is now active. Now you see the light turned red. Again, that's because I put the plate back down. The circuit is broken, but we can now start the cycle. So all we have to do is press the blue button and it starts, and the bit comes down and it touches the plate, moves up a little bit and comes down a little slower and touches the plate again, and now our Z is set. We're good to go. Remove the magnet and remove the touch plate and turn the router on and hit cycle start. And there we go. So what's cool is the software will trace the path as well as watching it physically. You can see here in gSender it is actually following along the path of the rectangle. And you can see it started in that top corner and then started at the top of the circle again. So that was from that node setting that we did. So now we're finishing up the circle and it's done. So now we turn off the router and get it out of the way so we can start doing our measurements. How do you measure? Well, we're going to do it with calipers. But look at that. That's what MDF is. It's all dusty. So calipers, you want a set of calipers if you are doing CNC routers. You have to measure stuff. And this is the set I like. It's got a nice big screen to it. It's accurate. It's industrial. About 40 bucks, I think. I like the color. It's called Ace Meter. I'll put a link down below in the description to get this set. I'm going to stock them soon in the IDC Woodcraft store. So now we're going to measure several points to see how the router cut. And this is exactly what you want to do with your CNC router, because if it's out, then you have to do some settings in it, or setting changes. So we're 5.992. It's supposed to be 6. It's very close. 5.994. Then we check it in the X direction, or Y direction, I'm sorry, and it's 5.992. I got a little focusing problem going on here. And 5.993, so I'm very happy with that. Then we'll check the circle. Now we're catty corner on the circle. 5.985, a little bit smaller. 5.982. So it's a little bit small, but I am very happy with that. Now you just take a metal scraper of some sort to lift the board up, get it off the bed. The CA glue works awesome. Remember, there'll be links down below for that, and links for a whole bunch of other stuff for beginner, and I'm probably going to have a setup sheet or a sheet for you that tells you everything that you should have with a CNC router. So now we clean up our mess. I just want to congratulate you for making it through this video. You've learned more stuff than what most CNCers learn over the course of maybe 4 or 5 months. And unfortunately, they learn it through mistakes. They spend a ton of time on YouTube trying to get their answers, Facebook groups, and they never really get the answer and have to try to figure it out themselves and end up ruining a lot of projects along the way. Very frustrating. So now you've got some of the foundations to help avoid doing that. So congratulations. You might have to watch this video again just to make sure you got it down.